And welcome. How's it going, everyone? Are we live? We are live. You can hear me. How's it going? Let's make our official announcement so we can get started. And more compiler work, in case you didn't know by the title or the announcement. As usual, hey, RPWH says, yeehaw! How's it going, RPWH? Thanks for tuning in. I hope you are having a fine time. Let us get started. Grammar to Parser Boy says, yeah, hello again. Hello, Grammar. How's it going? RPWH says, I'm doing good, thanks. That's so good to hear. Oh, yeah. Let's get started on this compiler, shall we? I kind of just want to delete all the things that aren't in the GitHub and see what we got, but I don't think I'm going to go that far. At least not today. I'd say we start just working on improvements, all around improvements, right? So let's try and check out the type checker. And I just feel like this is a terrible way to do things. Because you'll notice, suspiciously, expression return type has the exact same signature as type check expression, with one extra parameter to return the type of the expression it type checks. And it turns out that if we look at what expression return type does, it ends up type checking every node it gets. So I'm pretty sure that type check expression and expression return type are both the same thing. I don't think they have to be different. So I'd say we just work on that. So we just have to return the type of the expression that we type checked, and that will allow us to recursively call it all the way down, and eventually use continuations, just like our parser, for no recursive calls. Alrighty. Eternal Wild Fox, good evening, how are you doing? Are you working on your bytecode still? I remember that's what you were working on last time. I'm sure Grammar to Parse Boy is still working on backlang, because backlang is dope. Eternal Wild Fox says, doing fine, what about you? Not too bad. I just woke up, I finally found this product for this hobby I'm starting, and it's taken so long. There's like none in my town, and they're too heavy to get shipped. It's too expensive, so it's like I'm just waiting for one of the stores to be like, do you have this in stock? I've been calling them, but finally, I've got one. Sounds like my window just broke. Holy crap. We're fine. A bird might have flew into it, though. RPWH asks, what is English? RPWH asks, what hobby are you starting? Thank you, I appreciate the interest. I am starting blacksmithing. So I'm gonna start pounding on some metal with a hammer and making shit. I mean stuff. Grammar to Parser Boy says, I have not worked on backlang today. Eternal Wild Fox says, yeah, I am studying Pratt parsers. That's awesome. RPWH says, wow, that's quite out there. Sounds like fun. Yeah, I'm kind of out of regular stuff to do. I've learned chemistry. I've learned I've done everything. I've got to really reach out for stuff I haven't done yet. It's like, I'll figure it out. RPWH says sounds like fun. I might have already read that. Either way, I appreciate it. It is going to be fun. I'm going to be making stuff. Start with a leaf, right? Or a hook. Leaf or a hook, one of those. Pratt parsers. That's really cool, studying Pratt parsers. We have a Pratt parser, so you could check out ours. It's very cool. Or I could help you walk you through how ours works, I should say. Grammar says, I am currently learning how to play the theremin. Well, that's badass. I really love the sound it makes and the freedom of the instrument. That's awesome. That's literally like controlling sound waves with your hands. It's incredibly difficult too, so you should feel good if you can get any good sound out of it. Whenever I go near one, it's wow, and then I'm like, oh god, make it stop, please, and I panic. And then you see someone who knows how to play it, and they like put their hand in all these precise, like little pinches and points, and have like exact. It's amazing. I don't know how it works. I'm like, I can play a guitar, but that is too much. RPWH says, I'm just getting into mechanical keyboards. This is so awesome to hear what everybody's into. Going through the process of buying all the equipment to lube them up, etc. I want a Lily 58 split keyboard. So it's like, I don't know if you know, but it's a split keyboard. The Lily 58 is the layout. And I want to get it with these TTC bluish white switches. And I hope that it would improve my ergonomics a lot, because I could sit up straight with my chest wide. Grammar to Barcer Boy says, I can play some songs. You can play songs on the theremin? That's incredible. If you can hit notes on a theremin, I'll be thoroughly impressed. That is insane to me. Because theremin is it's like a violin on steroids. It's like there's no frets and there's no strings. Good luck. Eternal Wildfuck says, not sure yet how prat parsers work. For a part, it is mixed recursion and loop through tokens and eat them up while the precedence is equal or lower on the current token. Sorta. Yeah, it's just, you just keep parsing, but it depends where you put your result, right? Mr. Mugume says, I can build crap parsers. Nice. Like chopsticks, or like actual... The parser is crap, or does it actually parse crap? That's the question. But yeah, expression return type looks suspiciously like TypeCheck expression. So we're just going to have these be the same thing and go from there. So I think we're going to have TypeCheck program have issues because we now need like a type. I don't think it matters, but we do need one. Okay. Whoops. There we go. RPWH says the Lily 58 split keyboard looks gnarly. Thank you. Yeah, I really like it because it still has the numbers, which is kind of important in coding. I mean, it isn't. You could go to another layer for it and have numbers on like home row and symbols up and bottom, but that's a little too much of an adjustment for me. I reach up to hit the symbols with shift way too much to be able to adjust to that. Like, that is ingrained in my brain. Grammar du Boy says, yeah, it is not so hard if you follow the technique that Carolina Ike has invented and your instrument is tuned that one hand can fit into one octave. And my theremin can automatically correct the pitch if I want. You got auto-tune on your theremin? That's badass. That's pretty badass. You're like, oh yeah, I have a theremin and it's auto-tuned. That's awesome. And you have one hand can fit into one octave? That's crazy. So you have to have 12 positions that you have to remember for each note? That's complicated. That's very complicated. Grammar to Parser Boy says, yes, and I can see how far near I am from a note. Nice, like a tuner is on it. Grammar to Parser Boy says, muscle memory. Oh god. Whenever people say muscle memory to me, it's just, you know that thing that you've never had and never will? Yeah, use that. It's like, ah, yeah, that's good. I don't have muscle memory, I just have regular memory. I have to remember how to do it, and then I can go, oh yeah, that's how I do it. Node pointer type. What's the issue? It's probably being called from a whole bunch of places. Yeah. We'll fix it. We'll fix it. So we have this result type, and we would like to start mixing expression return type and type check expression. So if address of is not a variable access, we currently just say you cannot do that. And I think that's a valid type check. And we know, so now we type check to ensure child is variable access. That's definitely a valid to do. But now, RPWH says as flying through Emacs. It was rough. But you're right. I have muscle memory for like typing. You're absolutely right. Grammar 2 Parslet Boy says, and it's not so hard if you have a music experience like playing other instruments. I definitely do. It is less frustrating if you know how to play a song. You only need to find the notes. That's the frustrating part. I have trouble on like a violin because it's like, where are the notes? I can use my ears. It just takes, I have to find each one, and it's like, that just requires a lot of expertise I don't have. Eternal Wild Fox says, ideally I need to see some code to understand the Pratt parser further. I found a link with Java code. Nice. If you need some like basic pseudocode, I can help you out somewhat. Mr. Mugme says building a computer on a breadboard is also a bit like building a theremin. It just doesn't make sounds and rather calculations. Oh my god, you're so right. I've had times where a circuit only works when I'm holding the breadboard. When I put it on like a wooden table, it would just start doing the wrong thing. Like I built a 7-segment display on a breadboard from binary coded decimal, which is really easy. But anytime I brought my hand away, it would just start displaying not numbers, just random lights would pop up. I'm like, ah, good. This is good. I understand this. Eternal Wild Fox says, mine book also explains it in C code, but it used function pointers, which I don't fully understand. Just picture it as a function that you can call. That's a variable. But I get why you don't understand them. They're very confusing. And I'm sure a book explaining it may not explain it in the best way. This is so cool. I love hearing from all of you about what you do. But yeah, Eternal Wild Fox. There's a... Oh. Eternal Wild Fox. Okay. Let me see if I can find this. The Natalie programming language. The person who made that made a video on Pratt parsing that was really good. I can't remember what his YouTube is right now. So here, I'm gonna put it in chat for you. I don't know if this will help you, but the person who made this parser for this programming language made a YouTube video, and they went over how the parser works in depth in their own simple language that looks a lot like Python. And I remember that helping me a lot. So check out the Natalie language if you are looking for info on Pratt parsers. Because I feel like he explained it in a really simple way that let me understand, like, oh, it's not magic. I just remembered that from when I first learned about parsers. Eternal Wild Fox says, I found stuff with stuff. Okay. This is very confusing. All this, yeah, oh god. What is a parslet? This guy just made up words. Parslet is not a word. Okay, I gotta show this on stream, because this is awesome. So, Eternal Wild Fox found this on Pratt parsers, which, he looks very professional. Yes, obviously, Pratt parsing, peanut butter and jelly is how you just slather it on. How is this simple, by the way? What is this class? What is expression? He doesn't explain anything. So, oh wow. What is this? How is this helpful to anybody? Oh my god. Okay. I'm not sure what I'm looking at. It looks like Java code that is heavily object-oriented for no reason, which is Java code. What is a Parslet? We'll call these chunks parslets. What is a chunk? A chunk of a map from token types to chunks of parsing code. What is what? What? So a parslet is just a function? I'm so confused. So he creates all these different classes that this is just confusing. I can't do object-oriented. If you can do object-oriented, I'm sure you could figure this out. But I'm not sure what's going on. Eternal Wild Fox says, this guy also wrote the crafting interpreter book. That's another one I couldn't understand, so it makes sense. This is too heavily object-oriented for me. I don't understand how this is needed. You don't need this. Why is this a class? I don't get it. Why are these classes? Like, tell me, what is a parslet? Why can it not be a function? Why is this not just prefix and a function? Why is it a parslet with an expression parse class, which just returns a string? It's like, oh my god, this is so overly complicated. This is definitely what you'll find out there on compilers, though. Everybody makes it very complicated, and it's very sad. It's not that complicated, I promise. You should look for that Natalie one. It's way simpler. It's basically, there's two routes. If precedence less than or equal, put result on left or whatever. That's probably wrong. Yeah, put put current result on left, right? And then if precedence greater, the other branch, you just say, basically, put and parse into right, right? Yeah. Basically, you just affect the generation of your binary tree in two ways. That's it. RPWH says object obfuscated programming. Lamar OOP. That is a great t-shirt. That's so good. RPWH says object obfuscated. I don't know how to spell that either. Programming. That's probably right. Obfuscated? English is hard, man. Eternal Wild Fox says, oop, programming is nice, but sometimes people overuse object obfuscated programming. For sure. This is so good. This is what I would apply to the crafting interpreter's book. Object obfuscated programming. It just makes it so confusing. Like, what if instead of having an AST, where you have an integer, and on the left-hand side, you have, like, 1? What if instead of that, you had a node, which is an expression, which is an integer, which happens to be a literal node, which happens to be a base node. This is the proper object-oriented way to do things. This makes it simpler to understand the structure. So good. Mr. Mugume says, it isn't that bad. If you have to say something isn't that bad, it is generally pretty bad. But you're right, it's not that bad. It's just my brain is not object-oriented. I can do, like, verbs as objects, like, oh, this is a renderer, this is a processor, this is a thing that does thing. But as soon as it becomes like, this is a thing, which is just a thing, and this is another thing, it's just a thing with a different name, and this is another thing, it's like, too many things, my brain got confused. 3 things, and that's over my limit. I should probably write code today, but I'm having too much fun. With you all. Because you're all such wonderful, lovely people. And I say that with 100% honesty. So with address of, it returns a pointer to its base type. So we're basically just going to say type. Also, this is going to be annoying. Since we don't return a type, how about we update a pointer? Could we do that? Then we can just construct our type. Rather than, I don't know, we'll just write into an existing type node for now. Yes, and now type is a problem. So this will be like result type. Why not? Mr. Mugame says that's why I like JavaScript. Oh no. There you can just do what the fuck you want and nobody cares. Have you seen TypeScript? People care. Except the person that has to understand your code. Exactly. If anybody wants to actually run or use the code you write in JavaScript, it's hell. But as long as nobody uses it or runs the code, writing in JavaScript is a blast. You get so much done. I know exactly what you mean. The trick of OOP is to write understandable code. Yeah, that's the trick with all programming paradigms is the thing. It's so funny. It's so funny. Result type. And we're basically gonna have to say it has a child. Ba-da-ba. Also, when we node free children in that other spot from the other day, this misses next child pointer of of children node. Does it not? Fix me. Hey look, I remembered a bug from days ago. Okay, so we don't need expression return type. So let's do integer, for example. Let's just do this part. Also, I didn't mean to do that. That should have been a thing. Yeah, whatever. We'll get there. I'm sure we had an error somehow, and it was like, yeah, it's not gonna work. So type check expression. If expression is an integer, it shouldn't be too complicated, I don't think. We just have to say result type is an integer. Result type has a child. Result type child, here, we'll do it this way. So this is the size of the actual, do we need to do this? Or do we just need to return integer? I think we just need to return integer. I don't think we need the size of the integer as a thing. Because this isn't parse get type or anything. Well, we'll try it. We'll try it. Adderson28 says, hi Lens, hi chat, how are you doing today? It's great to see you, Adderson. I'm doing okay. I've had a good morning. I finally got a piece that I needed for my hobby I am starting up. So it's like, yes, it's heavy and it's expensive. So, and it hasn't been in stock for like weeks, but it's finally here so I can start. It's nice. How are you doing, Adderson? It's great to see you. Thank you for tuning in. Eternal Wild Fox says, I'm thinking how to mix recursive calls and iterative looping to implement the Pratt parsing. I have a feeling I make it harder in my brain than it has to be. Possibly. I'm really good at that. I'm really good at making things way more complicated than they need to be. See, I don't think, because we never need the size of a type unless we're actually like doing code gen. And we're not doing code gen from here. This is a type check. And we'll never type check while code genning. We'll type check, then code gen a type checked program. In which case we can just look up the types in the environment instead of doing this. So I'm just gonna remove this. Hopefully this doesn't break everything. Adderson28 says, that's hard work. I'm doing well, studying and working. That's good to hear. That's it's never a bad thing to do hard work, unless it's too much and then you feel stressed. Then blow it all off and go have fun. Terrible advice professionally, but good advice mentally. Take care of you first. So then result. See, I feel like we could have done pointers in a much better way. That would not require so much allocation. See, okay. Here's what we should have done, by the way. In case you don't know. Remember when we were going, how do pointers work? What are we gonna do? How do we tell if something's a pointer? And then we're like, oh, we'll just make it a pointer and have it be a child and have it a type symbol or another pointer. That's dumb. Don't do this. We made a mistake, by the way. I've thought about this ever since we've been having so many issues, or I've been having so many issues conceptualizing pointers and type checking and everything like that. And this is a way to do it, but this is a way that we're not going to do it in the future. You know what would have been easier? We could have just done this. We could have a character is pointer. If it's 0, it's not a pointer. If it's 1, it is a pointer. Then we can have a character that says in direction level. It could even be pointer in direction level. And then this can store the amount of indirection to the type, and if it is a pointer, this will be true. You could even not have is pointer and just have like node is pointer, and it could do bit shifting on the pointer in direction level to get if it's a pointer or not. We did it in a very dumb way that requires lots of node allocations when there shouldn't be one. Eternal Wild Fox says, mine idea, build a table with the precedence, and when I am an expression, consume the tokens while the precedence is equal or lower than the current token. With other words, -1 times 1 plus 1, the negative should be -1 times 1 plus 1, if I am right. I think unary negation operator has pretty high precedence. I think that goes above multiplication, if I'm correct, because if it's a subtraction, you're correct, it goes outside the parens. Mr. Mugame says RAM is cheap right now, it's fine. Lamau. Okay, we'll do it. Allocate more nodes. We should also work on our node allocation, doing it less dumb. Okay. So the children type is going to be whatever the type of this variable is. So we need the return type of this variable access. So what we're going to do is this. Variable access type. Why not? We're going to allocate a variable access return type node. We are going to recurse into TypeCheck expression. In our current context, we didn't change anything. In the same context to enter, in case we enter one, which we won't. But we want to send in expression children, which we've now type checked and is definitely a variable access. So this variable access, we are going to get the return type. Excuse me, we're going to get the return type. There we go. Into this node we have here. Then we don't have to allocate this. We can just, this is going to be better. I can't type or think. Eternal Wild Fox says, yes, I mean the minus should work on the 1 times 1 part only. The minus should work on the 1 only, because it's not a minus, it's a negation. It's an opposite. Negative, right? Because that should be something like this. -1 times 1 plus 1. I'm pretty sure that's how negative numbers work. They have a higher precedence than multiplication. Unless you want to have it like -2 times 4. It's still going to be -8, whether you multiply the positives or not. So it doesn't matter. Eternal Wild Fox says, oh lol, indeed the negation only should work in the -1. Yes, but with multiply, you'll get the same answer. But it becomes confusing if you do things like divide, because you'll get different answers. It's fine. People using infix notation be like, exactly. Parsing infix notation is the bane of a programmer's existence, I guarantee you. It's the worst one. It's the reason Pratt parsing exists. It's the reason so many types of parsers exist. Recursive descent, blah, blah, blah. Like, if you just parse prefix notation, everything is easy. Or if postfix notation, everything's easy. Because you get all your data, and then you use it. Or you get all your data, or you get how you're going to use the data, then you use it. It's like, it's so easy. LanderXT said, I don't have the notifs role on my new Discord, so I missed the announcement. Oof, I'm so sorry. I can get you in that if you want it. I know your last one was in there. You're in it. If you don't want in it, let me know. You'll be out. Lander is now in the notifs. Mr. Mugume says, memory management is #1 for the compiler dev. It's true. It's not, but it's true. Why did that do that? Is this indented too much? What? What's happening? What just happened? It just broke my indenting, but it's back now. Everything's fine. So we have a variable access. We'd like to type check it to get its return type. And then we're basically going to say, yeah, set the result type as a child to that newly allocated return type. And then set the result type to a pointer. So it's a pointer to whatever the variable, oh, excuse me, I didn't expect that one. The variable access return type. I had a bunch of tomatoes this morning from my garden, but I don't normally eat in the morning. All right. What do we do? So we have an address of return its proper type. We have an integer return its proper type. We need a variable access to return its proper type for this to work. So let's think about how a variable access works. Well, let's not think about it. Let's go copy it from where we have already written it. So we're going to need a context iterator if we're going to be doing a lot of things. So we're going to save the original context. Nah, we're going to keep context as the original context and just say context iterator. We'll just do it so it's easier. Is equal to context. So we can just use this instead of context wherever we need it and change it. Alrighty, so in expression return type for variable access, where are we? Yes, here we are. Eternal Wildfox says, it would be cool if I could fix my bytecode-based math expression engine today or tomorrow. That would be very cool. Eternal Wildfox says, after that, I believe I'm ready to really build a programming language. That's exciting. I would argue you already have. But I know what you're talking about. You're like, nah, this next one's the one. I'm gonna hit a home run. I get you. So we're gonna get the thing. And we use temp node in this case. So let's just check out how we can change this up. So we want context iterator. Context iterator. Okay, so we have a variable access, and we want to get the type symbol from the variable's environment using the variable symbol. I feel like we should have type symbol compare as well. That's a good idea. It would simplify many situations. Alright, I've been streaming just over 30 minutes. I'd like to remind everybody to check out the Discord if you are not already a part of it. We have a great time. There's notifications every time I go live. And you can ask to join a Discord role and be pinged every time I go live, so you will never miss another live stream. And we have a ton of fun. You can get code review, you can talk to each other. We all learn so much, and it's a great environment. I really recommend it. As long as you are ready to be positive and nice. There is also the YouTube down below if you want to check out any previous broadcasts. In fact, all previous broadcasts. Did I just catch? Hey, Sergey Lunev, thank you so much. Good to see you in the Discord. Thank you for coming in. we are very grateful to have you. In any case, the YouTube has all the previous broadcasts that I have ever done, so you can check out how we got into this terrible mess of a code base in the first place. And effectively, you can see how we got here. It may take you like 3 straight days of watching YouTube, but you can see how we got here. Also, be sure to check out that Twitch follow button. I said check out. I meant to click on that Twitch follow button. I can't speak this morning, in case you haven't noticed. It's pretty crazy. But yeah, click that Twitch follow button. We are almost at 100 followers. It is so amazing. And we are a growing, thriving community. I'm so thankful to all of you. LandarXT says, I managed to get OSRS open in time for you to show my name in the Discord, so it looks like I actually play a game and don't just sit around every day doing nothing. Lamau. You're playing RuneScape. Like, nah, I swear, I play RuneScape all day. I swear, I do things. That's so funny. Lando, that's really funny. Eternal Wildfuck says, let me think, how can I implement the prat part without obfuscating mine code? Lamau. Well, you can implement it any way you want. It's your prat parser. That's the best thing about code. It's your code. You can write it whichever way you want. As long as you understand it and it gets the job done, it's not really an issue. So instead of using temp node here, I think I want to create a node that's going to be like node symbol or type symbol or something. I know this is horrible, and we've introduced memory leaks out the wazoo, so just don't worry about that. We haven't built the entire thing. This is not good. Okay, so I need to build debug and run the function. Not run the function, and run the generated executable. I really am not speaking well to this morning at all. And let's just run like our pointer example. Oh yeah, I'm in the wrong thing to do that. I gotta go load our editor unmode. I really gotta add this to my my Emacs config, so I just load this file automatically. Perfect. Okay, I kind of want to highlight numbers or something in a certain certain color. So can we compilation exited abnormally? Okay, still gotta run it from here. Okay, it's we didn't quite succeed. What do we got? We have an error from TypeChecker.c on line 58, and it says you can't call TypeCheck expression like that. That's an expression return type. I wish I, okay, so I'm just gonna do if 0. This is why conditional compilation is baller, by the way, in case you were wondering why it was ever a thing. What else? A label can only be part of a statement, and a declaration is not a statement. Remember when I was talking, chat, remember when I was saying sometimes it lets and sometimes it doesn't lets? This is that time. Eternal Wildfox says, I would like to write some code. When I come back a year later, I still can understand the code by looking at it. Ooh, that's a big goal. Eternal Wildfox says, then you write good code. Absolutely. Absolutely. You at least write understandable code, which makes it good. So we can't create a type symbol here. And I'm not exactly sure why. We can't create a node here because it says, hey, that's not allowed. In TypeChecker, when we used original context, we can now use the iterator and just use the regular context. Looks good to me. We don't mess with the context anymore, so we can just keep using it. Okay, context it, context it, context it. Did I update the, I didn't. I knew I missed one. Haha. Missed that one too. There is no original context. Context. Parse get type. Context. Sure. Okay, we did it. So, as for up here, can we now do this, or are you still not allowed? You still say some stuff about a statement or whatever. Too few arguments to function type check expression in typechecker.c on 241. So type check expression in function calls itself. We're not here yet. We're not here yet. Can I just, how far? Where do we break? We break here. Can I get this on screen, please? Jesus, why break? I think that's good. What else do we got? We still have the label cannot be part of a thing. We'll get there. If anybody understands what this error message is, by the way, please let me know. A label can only be part of a statement, and a declaration is not a statement. Does that mean a declaration returns a value? I was fairly certain a declaration is a statement. This doesn't return a value, so it's not an expression. What is it? Is it a declaration? If it's just a declaration by itself, why is it not allowed inside of a label? Like, can I do this? I'm just curious. I know this won't work. More undefined references to expression return type. Yes, we call it a lot. That's fair. At least it builds. We compile now. So it's literally just because the literal label is followed by... Man, this is confusing. It's just because the label is followed by a declaration, and you can't do that. So do I literally just have to do like this? This is this is horrible. Yeah? You get where I'm going with this? And it works. Chat. This is horrible. Is needed for some label is followed by a declaration error or what have you. Okay. I'm not sure why this is needed, but it is needed, otherwise we get a bunch of errors. So either this is totally bad C code and will fail, and we shouldn't be how we are, or this is just, we just gotta trick the compiler a little bit, because it's a little sensitive. So we have type symbol, so let's just print to do, figure out return type of variable access. Lookup symbol in, and I think we can just use type symbols for type checking. I don't think we have to look them up in the environment, but we'll see what we do. Because, yeah. So the return type of the variable access is just going to be type symbol. So maybe we don't need to do this after all. Maybe we just write into our actual result type if we're just going to use the symbol. Well, then what do we do in a variable access? I feel like there was more and we didn't do it. This looks up the symbol. What is this? Star iterator equals star temp node. iterator equals type. So that just copies over, no, that's a pointer. So iterator equals this. We go all the way to children to hopefully get to the symbol. And then we search the symbol in the types environment into temp node. And then we say iterator equals temp node. Because iterator points to type, which is our result. So effectively, we've updated the symbol to this type. That's very overcomplicated, and we could just compare the symbol, could we not, without doing all of this craziness? Also, this is horrible code. I'm embarrassed. Can I just do this? Still more undefined references, but it does build. It does build. So we're going to have to figure out these undefined references and how we can get rid of them at this point. Because address of should be changed. So dereference calls expression return type, which no longer exists, and it calls it on its child. So all we have to do is say, hey, do the same thing, but just call type check expression. And we can say if result type does not equal pointer, dereference may only operate on pointers. That took me a while for that to click. I'm embarrassed. And then we can basically just say something like this. Result type equals its children type. Because it's a dereference, we'll eat a pointer, right? This could work. This could work. So we're basically saying the type of our result, which we've written into here, is actually the child type because we've eaten the one pointer. Okay. Eat the pointer. Do we need to do anything else? Do I need to say like result type children? Probably. I should probably just say this. Right? Probably just copy over like that. Well, these are pointers. I could also do that. I don't want to update the result type pointer. I want to update the memory at it. So yeah, this is what I need to do. Dereference the child, get the node that's actually here, the data, and copy it into this node. It eats the pointer. So that's another expression return type removed. We're not dealing with the function yet. We'll get there. Get return type of left-hand side variable dereference adjusted. Exactly. So now we can type check expression on the left-hand side into result type, I would say. Well, that's a variable reassignment result type is still under debate because we don't know what should happen necessarily in our language if we do this. New number is an integer. Should that be allowed? Should you be able to assign an integer from this, and this would just, you know what I mean? Should this return the integer value of new number? Should it return, like what if we did equals 69? Should this expression here return 69? Should it not be an expression? Should it be a statement and it doesn't return a value? It's confusing, right? What should we do? Or it could return like the variable access itself. So you could do things like new number integer 69 plus 32, and it would it would give you the proper thing still. But it would also work if it gave you the value. It's so confusing. And type checking, what's the return type of it? It's like, that's hard. So in any case, we don't know the result type of a reassignment. We haven't really decided, so yeah. I'm going to say left-hand side return type is in result type. Sure. Get return type of right-hand side expression. So type check the expression into result. So we will have result type, which is our left-hand side, and we'll have result, which is our right-hand side. These are terrible names. We could use type, we could use value, we could make up a new thing and call it right-hand side. Let's do that. We're going to call this right-hand side return value. Yeah, how about that? And then we'll just free it right down here. And effectively, if there's an error and the right-hand side return value does not equal the result type, which is our left-hand side return value, then hey, we've got an issue. The left-hand side is in result type, the right-hand side is in right-hand side return value, and this should be done here, but also here, so that's kind of annoying. How about that? That's good enough for me. Okie doke. Let's think about what we got. Still just a few more undefined references. It looks like 3 of them. So thinking about what this does, we get the return type of the left-hand side and also type check it to make sure that if it's a dereference that it contains a variable access and stuff. Good. We type check and it return the error. We type check the right-hand side and return error if we find one. And we then compare the left-hand side to the right-hand side, print out a big ol' fat error, and say, hey, you screwed up, or the compiler screwed up. So let's move on to binary operators. Type checking a binary operator. Effectively, we get the global context. We look up the binary operator in the global context, because that's the only place they're allowed, at least for now. Get global context. Get binary operator from global context. Environment, or whatever. We'll just call it from global context. So then we need to get the return type of the left-hand side of a binary operator. We need to get the return type into type. Okay, get expected return type of left-hand side in temp node type. So we get type from value, which is our binary operator, into value. So value is our binary operator definition. So it should have precedence. It should have a return type and a left-hand side return type. So we look up the symbol and then do a type compare. Right? Do we need to do we need to resolve the symbol of the type? Effectively is what I'm asking, because this will break if it's a pointer, right? If it's like a pointer dereference. So what if we just have this be the return, the expected left-hand side type? So we have to compare this to the actual type of the left-hand side, which we've got in type. Okay, so we'll just type and temp node will compare. We'll call this like, do we ever need it? We don't ever really need it. We could just name it something specific, like left-hand side return type, but we'll go temp node for now. So get expected return type of left-hand side in temp node. Good enough. We'll say into to keep our language consistent. Woo! Yeah. So then we compare type and temp node. We have temp node, which contains the type, the expected return type of the left-hand side. And then we compare all those. And then we do the same thing for the right-hand side. So basically, we just need to say that this expression return type matches the expected return type. I'm starting to get it now from the environment. So get expected return type of right-hand side in temp node. Let's say into temp node. Get return type of right-hand side in type. Which is what we do here. Get expected return type of right-hand side into temp node. Is this not the expected return type of the left-hand side? Value, children, next child, next child. Let's look at what is it? Parser, I'm sure. Parser.c. And we're going to look for operator. They've got to be somewhere here. Here they are. So binary operator, I guess we could also look at binary operator. See, we should have children, next child, next child, next child. That would be the right-hand side type. And we don't have that. So we've been, that was an error for a long time in binary operators. Good thing we only had integer on both sides. So we get the expected return type of right-hand side into temp node. We compare type and temp node because type contains the return type of right-hand side. This is the expected right-hand side. And boom, just like that. Then we just have to set result type to, what would it be? What would it be? It would be value children. Next child. Whoops. Because we have value, which is this binary operator definition, and we have precedence as our children node or pointer, then that next child will be our return type. Still more undefined references. Let's keep it going, baby. I'm sure this is just going to break everything. It's going to be horrible. So we get the return type of the given parameter. And type check the expression while we're at it. Expected type symbol of parameter found in expected parameter. So we have expected parameter, this iterator. And then we have iterator, which is our given parameter. Okay. So the expected type symbol of parameter found in expected parameter children next child. Okay, so our expected type symbol. We have type result iterator, and so we basically create our node pointers as we go, our pointer nodes, I should say. So what this is doing is creating a result as we go through this little loop here. So until we reach an expected type symbol, we're going to go, okay, one more level of pointer and direction. And we keep creating that node and making it a child of our result until finally our result can be written with the type symbol return value. So truthfully, and this equals result, so I should just copy result to our return. So then we say what? If type compare result and type. So what is result? Type is the given parameter. Result is presumably this entire built crazy thing. And then we type compare resultant type, which is the expected and given parameter types. And then we say, hey, argument type does not match. This, this is very messy. We have a fix me. And then we go to the next parameter until there's no more. I think that makes sense. It's a little insane, but it makes sense. I think we could do very well here if we could get everything using type symbols in this stage of the compiler. Everything would start to become much more cleaner without having to rebuild this pointer tree from scratch. Then we say not enough or too many arguments. I don't think that'll change. And then we're done. There's just one, which is what? Get return type of left-hand side. Oh, we didn't change that to typecheck expression. But we meant to. Hey, look, mismatched types. And here's that case where we have one returning a symbol and one returning a literal type. So a variable access looks like it's returning its type symbol and not its resolved type, which I remember doing that, so that makes sense. And then the right-hand side says, hey, this is an integer. It's just an integer. So this doesn't match. So we have to look up and resolve our type, or have an integer return its symbol and start comparing symbols, which I kind of want to do. Should we do that? I feel like we should do that. Yeah, I feel like we should do that. Type checking doesn't really need to know the size of a type or any semantics about the type itself. I guess it may eventually. Yeah. So we'll have it resolve the type. We'll have variable access resolve the type, which we did up above. Something like, I don't know why we did this, but we did do this. So we'll just copy it and break it down. I think that's it. Okie dokie. So now in variable access, our issue, Nexovec says, what up, man? What's up, Nexovec? It's great to see you. We're fixing our very dumb type checking. So why would we copy temp node into type? We have our, also this is in the wrong spot, Lamau. I thought that was a variable access. This is a variable access. Okay, this makes more sense. So effectively, we have result type. We want to copy result type into type. Sure. So now type may be integer, or type may be pointer to integer, and we want it to be something like not that. So we're going to convert nodes like this into nodes like this, doing this. Okie dokie. We would like to use the iterator for all of this. Looking good to me. So good to see you, Nexovec. Thank you for tuning in. Also, Neg Vorsa said hi earlier. I'm not sure if I missed your chat, but I'd like to say hi right back at you. Hello? So now we just have to say, not iterator equals temp node. Why would I do that? Because iterator equals type. Whoops. So if iterator did not equal type and we didn't copy, then that would just be result type. But let's use iterator and have it be equal to result type. And then we'll say, get the child, get the type in some environment. I think this is what parse get type does. So I'm just going to give it context, our ID. What is our ID? It is iterator. And our result, which looks to be temp node, can get rid of all of this and say error. If error.type, we can say, we're going to error prep here and say error type. Could not get type. Well, this might be an error generic. This isn't a mismatched type. This is a could not get type node from types environment. So could not get type definition in current context. For, what is this for? A variable access. Could not get type definition in current context for variable access. That's not that useful. It may be not ever useful, in fact. But we'll do it anyway, just in case. We could even print like variable, right? And it's like expression value symbol. Whoops, symbol. Excuse me. Thank you. We're getting there. We're getting there nearly. So now the right-hand side type, the integer, doesn't match because the left-hand side is now looked up in the types environment. So we're kind of mix matching between resolved or not resolved, which means in our integer, then we just have to do our dance that we did before. This thing. And result type. Exited with code 5. Hey, we got our first code 5. Nexovex says, I've been chatting with people on your Discord. They each have their little project. It is very cool. Yeah, we all are working on all our things. It's very cool. I'm glad you're having fun in the Discord. But yeah, we've got Eternal Wildfox working on math expressions. We got Grammar working on assembly and his backlaying. We got so much going on. I think LandRXT is working on the no, Mr. Mugame is working on the breadboard computer somewhere here. Lamau Nexovec. Pain. Pure pain. The breadboard computer's here somewhere. We got an OS. I think someone's working on the OS. Waffle working on an OS. Very cool. It's all very cool. It is fun to follow everybody's little scenarios, right? So result type children equals node allocate. What if I did something like this? Node pointer size of integer. And then these are going to be I think that makes sense. Do I have node integer? All right, we still exit abnormally. I'm not sure why, but we can figure it out. So we just changed how variable access works. While iterator children. Iterator is equal to result type, and result type is equal to environment get by symbol. So we are looking up a variable by the name of a variable. Looks fairly sane. Nexovex says no compilers for me for a while. Lamau, I need to get the game playable first. But I'd love to write some. I have some ideas for a language. That's awesome. I will be very interested. You mentioned you're working on a game. What are you trying to get playable? What kind of game? So then we use iterator to get our childmost node, right? From a result type. Do I just need to copy result type or something? I shouldn't, because this is part of result type and gets updated by temp node. So what happens if I print node results type and then exit? It looks like we got the right, yeah, we got the right thing. So our result type of what? So for a variable access number, it's an integer. I think that stands. Yep, variable access of number is an integer. Okay, so then in address of, you say if expression children type. So address of does have a child, right? We're not getting access 5 there. No, and if we look at our actual AST, where do we got? What do we got? Expression children type. So we're dereferencing an address of child. So if we look at address of, see, it has a child in every scenario. It has to have a valid variable access. So we'll say if expression children, we'll do like that, just to protect from a null dereference a little bit. So is it this type check expression? No, we can get through here and through here. So we can get through type checking this address of number, but not through the whole thing. So let's figure out what went wrong. So when we're type checking address of number, that means we're already all the way down here, no? For the variable access number. So in a variable reassign. So we get the return type of the left-hand side. So let's print what that is. Let's do our little tricks here. Okay, not sure what I did. So we do print something out, luckily. Do I have an exit in here still? I do. And effectively, we have a left-hand side of variable access number. Left-hand side return type is integer 0. We have a variable access numputter. Left-hand side return type is a pointer to an integer. That's all making sense. That's all making sense. Nexovex says, it's written in Lua in Love 2D framework. It is a multiplayer platformer. That's awesome. And the multiplayer takes a lot of time to get right. Yes, it does. Multiplayer is one of the worst things to handle. It's like, if you don't ever have to deal with multiplayer, you probably shouldn't. It's not a good choice. Okay. So our left-hand side return type is looking fine. How is our right-hand side return type looking? Right? I would like to print left-hand side. I would like to print right-hand side. And this is going to be in right-hand side. Whoa. It's going to be in right-hand side return value. So just show it all to me. So we have a left-hand side and a right-hand side of variable access number and variable access number. So either way, the expression is the same because I did that. So we have left-hand side is variable access number. It returns int 0, 0. We have right-hand side int 0, which returns int 0. Nexovex says, I thought it would be cool to have one of those top-down spaceship games I've played when I was little, but actually have a character in the ship you could care about and stuff. That sounds cool. I'm not a total noob, already had a playable version, but I was just passing hard-coded strings over network and it was ugly. So now I almost have the whole thing reworked. That's really awesome. Reworking is the bane of a programmer's existence. That's how burnout happens usually. So we have left-hand side, but then while type checking the right-hand side, we've exited abnormally because we have this exit and we're trying to do the address of. So if we get past that, right? So what if I exit here, I assume we never get here. So we fall through in type checking this variable reassignment, which means we should just return. And after this variable reassignment, we have a dereference on the left-hand side. Maybe that could be breaking things. Or maybe it's during code gen. It's not during code gen. So during type checking, we're still going awry. And it's late in the program. We've already done so much. It's just this type checking. So maybe a dereference is wrong. So print node result type. Okay, still doesn't work. Gotta love it. Still doesn't work. So we never get here. Which is interesting, is it not? Is it this print node? Trying to print type and not result type? It is not. That was probably an error though. What is our issue? So please just give me result type. Eternal Wildfox says implementing the parser rules. Oh god. Nexavec says the reworking was actually the most fun part of all of this, and it also taught me the most. I feel like I could design even a big system, no problem now, no joke. That's awesome. You're right. That's usually how it goes. Reworking is the most work, but you learn the most doing it. Okay. So we found where our error is. RPWH says, do you have any books, resources you would recommend for someone trying to get into systems programming? RPWH, I do not. I did not use any books or any, I did use resources. I just used the internet and I learned systems programming. It's definitely doable. RPWH says low-level stuff. I mostly only have experience in high school applications / scripts written in Java and Python. I mean, yeah, I just go write assembly. Make a goal like, oh, I want to call printf from assembly. I want to figure out how that works. Or I want to figure out how the stack works on like function calls and how do multiple functions call each other and how does that work? Or just learn what some basic, like look up basic assembly and then like, okay, jump. How can I use jump? And then try and make a program in assembly and write something that like returns 5. You know what I mean? Just start is what I would recommend. Nexavec says high school. I didn't even finish that. Adderson28 says try to learn about assembly language, RPWH. That's where you can go. Assembly is literally just controlling the hardware. Nexavec says assembly is great. He's right. They're right. They're right. So we can do this, and we can't do this. Okay. Maybe we're not catching this error. I did just sense that. But no, still don't catch this error. So whatever expression we're trying to do is breaking. And we didn't really make it clear. We'll do a bunch of new lines. So the dereference of numputter is causing some issues in our type checker for some reason. So numputter is a variable access, and it seems like it should be fine to do all of this. Adderson says, assembly heart. Nexovec says, no, I do have high school. Lol. What? RPWH says, to assembly we go. I might have read that, but that's awesome. To assembly we go. That's a good goal. You'll learn a lot how the stack operates and how current modern computers do computation. You could also learn like Ben Eater, like he talks about the low-level circuits, how RAM is implemented on a hardware level, how the CPU is implemented on a hardware level, how two numbers are actually, like he builds the circuits on breadboards. Mr. Mugume is doing that. But it's very complicated. I don't think you need that for a low-level understanding, but it definitely helps. Definitely helps. So dereference may only operate on pointers. So we're getting some issue in the dereference of variable access. So it's definitely our variable access code that's problematic. Hey, look, this should be context iterator. That may harm things. We don't have original context. Are we in the wrong function? We are. We're gonna get rid of this now. Variable access, thank you. We do use the iterator. I was like, I thought I changed all this. So we get our variable access by symbol into result type. And then we say while iterator children. So let's just like, what could be giving us a null dereference? I really don't know. RPWH says, I saw one of his breadboard videos, but I was a bit lost, lol. Yeah, it's definitely a deep dive. You have to know kind of some basic electronics and other stuff. Like watching Great Scott or Electro Boom or people like that may help you out as well. Okay, so the idea (108) is equal. 108 is in another one. What are you talking about? Maybe I just changed it, but line 108 is this in address of. This is fine. I think this is fine. Maybe the line number changed, negvorsa. This says not equal variable access. And then if the child of an address of is not a variable access, we go, hey, that's a problem. We definitely break here, we break here. I think we're good. That's an and, that's a not equal. Everything here is good. So effectively, what do we got? We have Adderson28 says eats good. I was just thinking we probably could do if not children or. Because then if this is null, we'll return this error. Or if it's not null and the type is not variable access, we'll return this error. I think that's better. But that didn't really matter semantically. Still got the still got that null dereference, baby. So let's think about it. We are in this switch case for a node type variable access. We would like to use the context iterator to get an environment from the environment, the variables environment. We'd like to get the variables environment. Get a binding from it, bound to symbol. So let's just say, print out our little symbol for us, please. Okay, print out our, I just want to see what we get. We just get variable access number. So we should definitely have a symbol. Everything should be fine there. So iterator result type. And we print node iterator and then exit. We have symbol integer as our iterator. Okie doke. That seems like it. That's exactly what we need. So now what do we have in our temp node? We have int080. So we went from symbol integer to our integer definition of the type. I guess this may not be the proper control flow, like the actual one that is erroring, but still. So what is iterator? And why? So we get the type from the symbol iterator into temp node, and then we say iterator equals temp node. Yeah. I mean, this should be fine. Iterator is always something, and so let's do like if not iterator, and do big red flag, right? We don't have a big red flag, if not iterator or not temp node. We're not doing null dereference here. This is so bad. We should just get out the debugger, because I'm sure it will point us right to it. Chat, we're doing it. We don't like doing it, but we're doing it. It's the debugger. It's time. Windows. Fun compiler. Rohan says, good evening, my child laboring code 5 generator. I have a code gen. I have a exit code 5 just for you, Rohan. Right now. Look at us. Every time I run it, baby, we get you that code 5. That sweet, sweet code 5. Context it equals context parent. Negvorsa, did you literally find it? Where is that? Context it equals context it parent. Iterator equals iterator children. I don't see that. Where is it? Negvorsa, you're scaring me. Where is it? This is context iterator. Context iterator. We have context here because that's where we're getting the type from. Our original context, not our iterator. That might be null. Rohan says, ooh, pog bones. Lamau. I don't know why this bug is happening. It's fine though. We'll find it. Let's see if this terrible debugger can point us to the right answer. I think we're going to need to do this once again. We built it, we ran it, and access violation reading location 8. No shit. Where are we? What? Parse get type. Tried to call printf. So type check expression called parse get type on iterator. Iterator is what? It's result type. Yes, it's result type. And so result type is equal to the type in the variables environment, which should be the symbol. So do we have the variables environment wrong? What's our context? variables, binding. What are we looking for? We're checking that the value is what? The value of a binding. What would the value of a binding in the environment be? We're saying it needs to be a symbol of an integer and not like an integer thing. So this is a pointer with node type 1. I'm pretty sure that's integer, which has a child of integer 8. Which doesn't make sense, right? That doesn't make sense. So how did we malform this variable declaration? Is that what's happening? So now in source parser.c, when we have a variable declaration, you're telling me that this variable declaration, when set in the environment, yeah, didn't we used to have type for environment? Where's that? Did we just delete that when we refactored the other day? We used to have type for environment for sure, and it's no longer here. So chat, I'm pretty sure we just deleted something. Yeah, because we have symbol for environment. I'm pretty sure we did type for environment. So why? What is our... Why don't we just use the type symbol with the pointers added on top as parents? Rohan says result type is what? Lamau. Okay, so in the parser, check for a function call or new variable declaration because we don't know what the symbol is. Rohan says just delete the errors. If we can't see them, they are not there. True. True. What you can't what can't see you can't hurt you. That's what the ostrich thinks, right? And the emu, stick your head in the sand, you'll be fine. So basically, for a variable declaration, we advance the lexer and parse the type into type. Type now has our type. Variable binding, we then say, make sure there's no redefinition of a variable, because we can do that very easily. We can then say it's a shell node, so we can get rid of it. Variable declaration. Rohan says, so basically stick your head in the code and you are fine. Basically, Lamau. Oh, Paug. Paug. Okay, this is unrelated, but I just got an email, a very positive email that I'm glad I got. It helps a lot. I'm gonna be able to go do something today. Yes. Awesome. More blacksmithing stuff. That's very fun. Nexovex says, plus, if they try to stick their head into concrete, the problem will solve itself. RPWH says, blacksmithing related? Yes. Nexovex says, you got a date. I would not be excited to get a date. I don't want to date anybody. Sounds hard. Too much work. I got shit to do, man. I got myself to work on. RPWH says blacksmithing related. I think I read that, but yes, it is. It's my my steel shipment. It's a not shipment, I guess, just my steel order. I found a local steel supplier that has no minimum order, so I bothered them. I'm like, hey, is it fine if I get like 4 feet of steel because I'm broke? And they're like, yeah, it's cool. So that works out. That's all ready. It's really exciting. Nexovex says lol. Nexovex says, you do blacksmithing? What? I do now. I just found an anvil this morning, or pretty much yesterday, last night. And I've got everything ready. I just need to go get my steel later today, and I'm gonna blacksmith. But yeah, I do that now, apparently. Add that to the list of like a lot. I guess I can't say Legal sucks. Legal problems. Rohan says, well, the anger about the errors has to go somewhere. Yeah. What do you think I'm gonna do? Swing a hammer into my buddies, my friends? No, I swing a hammer into some steel. Nexavec says, how do you even get the idea to do that? Be like really bored and never want to leave your room. And then eventually your brain, like, unless you either kill yourself in the room or you force yourself to leave and go have a reason to leave, right? So that's my reason to leave. RPWH says, I assume you need some kind of furnace. I'm just going to use a charcoal fire at first because I don't have access to coal yet. I'm trying to find some in my town, but it's hard. But I'm either going to make a propane burner eventually or move to coal. But yeah, I'm just going to make a charcoal fire in like, I have some bricks on the property, so I'm just going to line those up and put a hairdryer in so that the fire gets really hot because of all the air and it can burn. And then I just put the steel in there and hit it on the anvil. It works great. Negvorsa says Damascus blade, 1024 layers. I mean, yeah. I'm gonna be forge welding soon. It's gonna happen. Nexovex says, I know that and I'm still not a blacksmith. It made me a weeb though. Lamau. Rohan says, my reason to leave is going to work to enter another room and then go back to my room. Yes, you get it. It just has to be any reason. It's like, I'm gonna go to the fridge and I'm gonna get a drink. Right? That's like, you either stay in your room forever on, or you can go and get a drink. And it's like, okay, I'm gonna go get a drink. And then you go and get a drink and you like run into your roommate or whatever and end up talking to people. Things just happen. So how is our type incorrect? Love those code 5s. How is our type incorrect? So we parse type into type. So let's look at parse type. Because parse type should return the symbol at the end, but it should validate that it's the proper thing, no? So we have parse type, and we basically do, while there are pointers, do the thing. After that, get the type symbol, and with the type symbol, validate the type and return it. But here's the thing, why is this type symbol not a symbol? Do you see what I'm saying? It's like we're overwriting while type checking. Are we actually like dereferencing something we shouldn't? What if this right here is our issue? So what if iterator... Okay, we're gonna do it. I don't know if this will work. I don't think this will work. We're gonna have to do type. So we're gonna switch this back to type. No, that's still, yeah, we want to copy result type into type. And then we want to copy type into result type. Like that. RPWH says, learning the way of the blade. Aye, 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 aye. Yes, RPWH, you get it. Rohan says, but type is not type. Or is it type? Lamau. Rohan says, no, I hear what you're saying. There is no cam to read lips of. It's true. Hey, chat, we did it. I fixed it. Chat, I did it. We figured it. We fucking figured it. They're both integer. How does what? Why does left-hand side dereference and have left-hand side and right-hand side printed out, and then we have right-hand side return type? Oh, because they're return type. So this is the left-hand side return type. This is the right-hand side return type. You can now see they're exactly the same. Yep,